Now let's do an exercise using the forest plot. Let's take a look at an example. This study was published in Mutagenesis by Peng and colleagues. The purpose was to conduct a meta-analysis on the association between matrix metalloproteinases 2, 7, and 9, promoter polymorphisms, and cancer risk. Matrix metalloproteinases are enzymes that affect the matrix around the cells, so they help cement them. And if the matrix metalloproteinases are damaged, there could be potential opportunity for cells to reproduce and become cancerous. So these mutations were assumed to be dominant, which means that you would only need one to have an effect. Let's look at figure 1 for this study. And we can focus on the first study by Elander. This was looking at colorectal cancer. The first column are cases, the second are controls, and A and B are the mutations, whether there was a mutation or not. And then the odds ratio with 95% confidence interval are reporting here. The weight of the study is a reflection of the size of the study, and larger boxes will carry a larger weight. Using the forest plot, we can construct a 2x2 table for each of the studies, as you see here. The cases and control will be the same here. And A and B represent the presence or absence of the mutation, which are shown here on the table. So take a look at figure 1 in the study. And specifically, let's look at the Elander study. So from those results, we can construct a 2x2 table where we have the rows represent the mutation or not, which is A or B, and the columns are whether a patient was a cancer case or not, or was a control. So there were a total of 127 cancer cases and 208 controls, for a total of 335 individuals. The way then the table, that the forest plot, what the forest plot shows, they show the odds that the cancer patient has a mutation, which is 58/69, and the odds that the control has a mutation, which is 99/109. Now this is actually the exposure odds ratio, and it is 0.93. Now keep in mind that the exposure odds ratio is the same mathematically as the disease odds ratio. So if you were looking at the odds of having a mutation among cancer patients and then comparing that to controls, you would still end up with a 0.93. And just a reminder, the odds are different from probabilities. And so the probability that the cancer patient has a mutation is 58/127. So odds ratios are different from risk ratios. So for every line in figure 1, you can construct a 2x2 table. So now let's look at the Ronin study. You have a 2x2 table, and you can complete this, and then you can hit the pause button, and when you're ready, we can continue. So you're going to fill in the cells in the same way as we did before, calculate the odds ratio, and then determine whether this the confidence interval is crossing the null value. Now, this is again, we don't want to pay too much attention to the significance, but I just want you to focus on these particular results. So when you're ready, you can start again. These are the results for the table. So from the forest plot, you can construct a 2x2 table here for this study, and then calculate the odds and the odds ratio. So the odds ratio is 0.84. Now you have become epidemiology detectives. Take a look at figures 1, 2, and 3 in this paper. Do you see anything weird, strange, or just a little bit suspicious? Hit the pause button and think about it, and then when you're ready, you can continue. Keep thinking, look at figure 1, 2, and 3, and one or more of them could have a problem. Here's, for example, figure 1. Here is a tip. Take a look at figure 1. Look, for example, at the third study, Otani. What is the odds ratio? Is the odds ratio larger or smaller than 1? Would you expect the center of the box to be to the left or to the right of the null line, which is 1? Here's a figure 1 now. So if you are let's kind of focus on figure 1. Anything weird here? What you might see is that, so we are comparing the picture to the results. Now take a look at Otani again. All right, so the box with the estimate is in the center of the box, is to the left of 1, which is the null, the odds ratio. However, when you look at the right side, the odds ratio reported is 2.39, ranging from 0.65 to 8.8. The pooled estimate is down here. This is the overall. So you can look at also other studies, and you will see that there is a problem here. So what we're going to do then, we're going to do an exercise using this figure. At this point, we are confused. We don't know whether the problem is in the picture alone and the numbers are correct, or we have a problem in the numbers, and particularly we have a number in the overall estimate and confidence intervals. So is this correct and the problem is just in the picture, or is this incorrect? So you will actually redo the meta-analysis for these authors, and you will use a random effect model, and you will calculate the pooled estimate, and then you will give the answer.